Last but not least, in this section, we're talking about derivatives of functions that have really weird exponents. Notice this is not an exponential function. This is a power function. It's just that we don't have a nice number up here, and that's okay. Power rule still applies. So this one is on here just to show you you can still just do the power rule. So we bring down the square root of 2, and then you subtract 1 from the exponent, so you get square root of 2 minus 1, and you're done. That's all you have to do for that type of a problem. Same thing is true here. Pi is a number. It's not an exponent. It is an exponent. It's not a variable. So the only variable here is x. So this is where we can use that power chain rule, or you can do chain rule in general. So I want you to notice a couple of chains here. Here's my 2 chains. One here and one here. So my inside function is 3x. My w is 2 plus sine of u. And then my outside function is w to the pi. So I want you to find all those derivatives and put them all together. So I found each derivative individually, and then we put them all together. 3 times pi times cosine of u times w to the pi minus 1. And now we just have to put those numbers back in. So 3 pi cosine of u, which was 3x, times w, which was 2 plus sine of 3x, all of that to the pi minus 1. That's a fun derivative. Hokey Pete's. Last but not least, we've got example 6, natural log of x minus 3. They want you to find the derivative and state the domain of f prime. Go ahead and work on that one. This one was nice and easy with chain rule. The inside function was x minus 3 with a derivative of 1. The outside was natural log of u, so 1 over u. So when I multiply those together, I just get 1 over u, or 1 over x minus 3. So the domain here is that it's going to be all reals not equal to 3, except I need to go back to the original function. And we agree we can't have a 3 in here, but natural log is only defined when x is greater than 0. So in this case, when x was greater than 3, because that's where my new asymptote would be. So I can't just put x cannot equal 3. I have to take into account the domain of the original function. If it didn't exist for the original, it certainly is not going to exist for the derivative. So I don't want to put not equal to 3. We have to say it's x is greater than 3. So we're only looking at the right-hand branch of that particular function. I hope you've enjoyed 3-9. Have a great day.